Hello, am I audible?
Yes, sir.
Yes, sir, you are audible.
Yes, so I think you have a doubts in week 7. We will rectify particularly your doubts one by one. So just tell me.
So in practice assignment,
Hmm? Okay. So can I solve the complete practice assignment? That is better.
yeah, I think so.
Sir, actually, I have a questions.
Yeah, yeah.
Uh, Suppose I have a multiplexers and I
Hmm.
give the inputs that is a 3000 inputs. Then what will be the selecting lines?
So basically, like for example, if we have a 3000 inputs, just wait a minute. Always what we are doing, we have to take the log n. Okay, like we have a
Uh,
3000 lines, so we are taking the log n value. So now if you consider the log n, so your answer should be 12 point something, because with the help of 12 lines you can create 2048. Okay, you
yes,
have a
sir.
3000 lines, so you have a basically lines, select line between 12 point something. Okay, so we always consider the higher value.
It means 13.
Yeah, always 13. Why? Because with the help of 13 lines, I just draw a circuit. Wait a minute. Just give me 1 minute. Yes. So, like for example, we have a 3000 input lines. I think my screen is visible to all.
Yes, sir.
So we have a 3000 input lines. Now we have a select lines. Okay. So how we calculate the select line? So basically the select line is log 2 of input lines. Okay. So if we are taking the log 2, so log 2 of 3000, that is, I think suppose that is 12.5. Okay. So we know that 12.5 select line is not possible, either the value of 12 or the value of 13. Okay. If we have a 12 value, if we have a 12 select lines, so how many combination of input is possible? 2048. And we required a 3000. So that means 12 line is not a correct option. Now if we go with 13 lines, okay, so how many outputs, inputs will be possible? 4096. Now we have a 3000 input. So what we do, 3000 input are connected and remaining is 1096 inputs. I just make a ground. That means no input is connected on this one. So if I select a select line of this one, we are getting output y is equal to 0. Why? Because like for example, we are taking the 1, 1, 1, 1, 1, 1, 3, 3, 6, 7, 8, 9, 10, 11, 12, 13. So which input is selected? 4095. But we know that 4095 is grounded. So output is 0. So only input is possible for 3000 and remaining lines will be we are connected with the ground. Okay, so we always choose the higher select. Clear?
Yes, sir, clear.
Okay. Any other doubts?
Sir, can you explain the priority encoder with its truth table?
Yeah,
One
I
example.
just explained that one. Either initially we start with the practice assignment 7,
Okay.
that is better.
Yeah, sure.
After that, we explain the priority encoder. So the practice assignment 7, question number 1, the minimum number of input line required to decode a input of 496 outputs. Okay, so we know that input decoders are available either 2 cross 4, 3 cross 8, 4 cross 16, 5 cross 32, 6 cross 64, 7 cross 128, 8 cross 256, 9 cross 512. Okay, now we know that the output lines is in between 256 and 512, 496. So what should we do? We use a 9 input line. Okay, 5, 6, 7, 8, and 9. And we are getting a 512 output line. So out of 512, 496 output as it is, and remaining we connect as a ground. So that means only the output is possible on 496. Okay, so how many input line is required? 9. Okay, a number of logic level and the number of 2 cross 4 decoder with enable required to hierarchical build a 6 cross 64 decoder respectively are. Okay, so how many decoders, 2 cross 4 decoders are required to implement a 6 cross 64? So we required a 64 lines. So 1, 2, 3, 4, 5, 6. I just break into the multiple. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. Why we required a 16 at output stage? Because we required a 64 outputs. Okay. And we have a 2 cross 4. So that means every decoder have a 4 lines. So how many decoders we required? 16. Okay. So in this stage we required a 16. Now these 4 will be controlled by the one decoder. Why? Because every decoder have a 4 lines. So we connect a 4 particularly output with the 4 decoders. Enable pin. Okay, 1. Then for this next 4, we required one more. For the next 4, we required a one more. Okay, we required a 16. And for the next 4, we required a one more. Okay, so this 16 will be controlled with the 4 decoders. So 4 in this stage. Now this 4 also control with the one more. So the 4 output will be controlled by control these 4, and these 4 will be control the next 16. So 1 in this stage. So how many decoders are required? 16 plus 4 plus 1. That is 20. Okay. Now the number of logic level and the number of 2 cross 4 decoder will enable. How many logic levels we required? We basically implement this structure in a 3 level. Initially, this one, level 1, then second level, level 2, then third level, level 3. So how many levels is required? 3 levels is required, and total 21 2 cross 4 decoder is required. Clear? Any doubt in this one? Higher order decoder implementation using lower order.
Sir,
If we-
one question in this.
Yeah.
Like in one of the questions, it's been asked like these many decoders are available. These of one type and this of other type are available. Now
Mhm.
we can implement the ask decoder using the number of decoders which are there, lesser number of decoders than what we have given, what has been given. So that is
Can you
okay.
repeat your question? Can you repeat your question? Is that if
uh, like we have been asked
Mhm.
that you have to implement a certain type of decoder using
Okay,
lower order decoders.
okay,
So I don't want to ask the question because it's a graded assignment question. So that's the reason I'm not
okay.
giving
So, like
specific.
for example, you have to implement 6 cross 64 using 2 cross 4,
2 cross 4 and a smaller order decoder.
1 cross 2.
Yeah. So
Okay.
uh, we can implement that
Like for
decoder.
example, I am taking one thing is that if I am going to implement a 5 cross 32 decoder,
Right.
use the available is 2 cross 4 and 1 cross 2.
Okay.
Okay.
Right.
So for the 32, we required a 8 lines.
Right.
Okay. In the output, we required a 8. Why? Because every particularly will have a 4 output lines.
Right.
So 4, 4, 4 is in this type we required a 8 particularly decoder and the output stage.
Right.
Okay. Now for controlling the 8 output stage,
Okay. We'll need 2.
2 basically. Okay.
Right.
And 2 this particularly will be controlled, each particularly will be controlled with the, so this is 2 cross 4 everyone, this is again 2 cross 4. Why? Because this particularly 4 will be controlled by the 1, 4 will be controlled by the 1.
Right.
Okay.
Right.
Now the thing is that we have to control only 2.
Right.
So there is no need of 2 cross 4. So what we do?
We can use 1 cross 2.
1 cross 2. Why?
Right.
Because 2 particularly input, 2 particularly output is required to control these 2.
Right.
So 1 cross 2 is 1 required, and 2 cross 4 is 8, and 2 10 is
Right.
required.
Right. So if the number of, if it is asked that the you have X number of 2 cross 4 decoders and you have a Y
Y
number
number of
of
yeah,
1 cross 2
1 cross 2
decoder,
decoder. Yeah.
and we are able to implement it using lesser. If
Mm-hmm.
one of the options given has higher number of decoders used, and
Mm-hmm.
we can implement it using lesser number of decoders than
Mm-hmm.
what is given, so that is okay, right? We can select
Yeah.
we can select that option.
Yeah. That you can
Okay.
select that option also.
Okay. Okay, sir. Thank you.
Okay. Similarly, if you see that question number third, a 3 cross 1 mux is required to build a 9 cross 1 mux. Okay. So we know that practically 3 cross 1 mux is not available. Okay. We have to design a 9 cross 1 mux using 3 cross 1 mux. Okay. So we know that 9 cross 1 mux as well as 3 cross 1 mux is not available. So what should we do? We have a two different way. Is we have a 4 cross 1 mux, and if we connect a fourth line with the ground, so that will be behave as a 3 cross 1 mux. Okay. So we have a 1 3 cross 1 mux, another 4 cross 1 mux, create a one output line. Yeah. This one, and we have again a 4 cross 1 mux, connect this line. Okay, now we required a again a 4 cross 1 mux, convert as a 3 cross 1, and particularly use that one as a for the output multiplex. Clear? So practically 3 cross 1 mux is not available. Either the number of mux is 2 cross 1, 4 cross 1, that is 2 raised to power n cross 1, where n is select line. Okay, so we have to customize a 3 cross 1 mux using 4 cross 1. And how we customize that one? We connect a fourth one input as a grounded. So either which select line is there, output is 0. What is the final equation of your that one? If we have a 4 cross 1 mux, okay, if we have a 4 cross 1 mux, this is my y, I naught, I1, I2, I3. So what is y? I naught S1 bar S0 bar plus I1 S1 bar S0 plus I2 S1 S0 bar plus I3 S1 S0. Okay, this is my equation. Now if I3 is grounded, so that means I3 is 0. So this term is 0. Either you choose a S1 and S1, S0 both will be 1, but I3, because of I3, this term is 0. So this is your equation. So that particular equation is basically similar to the 3 cross 1 mux. So we can customize our 4 cross 1 mux in a 3 cross 1 mux. Okay. So how many 3 cross 1 mux required?
4.
4 3 cross 1 mux required to create a 9 cross 1 mux. Next is, I think this type of one graded assignment question, you are facing any issue?
Yes, sir. After solving this, what answer I got is not there in the given answers.
So I just solved this one in the for the practice assignment question number 4. On the basis of that one, you can choose. Okay. So generally, what we are saying is the decoder condition is that I1 and I0. Okay, and we can say the D3, D2, D1 and D0. So if both are 0 0, D0 is 1. If 0 1, D1 is 1. Okay, if 1 0, D2 is 1, and if 1 1, D3 is 1. Okay. Now here you can see D2 and D3, that is completely eliminated here. So either you are getting a D2 and D3 anything value that doesn't create any effect on F from the first decoder. Clear? So what is the basically equation for the D naught. D naught is 1 when I1 and I naught both are 0. So I can say this is the I1 bar, I naught bar. Okay. And what is D1 we are getting? D1 is 1 in this situation. So this is the I1 bar, I naught. So it is a I1 bar, I naught. Okay. And what we are getting here? I1 bar, I naught bar multiply with I1 bar, I naught whole. So this is one particularly input. This is my second input. I just solve it through the De Morgan's theorem. So it becomes a I1 bar, I naught bar, whole bar plus I1 bar, I naught whole bar. And if I break it again, so it is a I1 double bar plus I naught double bar plus I1 double bar plus I naught bar. So it is a I1 plus I1 plus I naught plus I naught bar. Okay. So that is one. How it is one? Because this is one. Plus I1 and I1 addition is I1. And anything add with the 1 is always 1. Okay, so here we are getting a 1. Now Z. If for D2 and D3, we see that I1 is always 1, I0 is either 0 or I0 is 1. Okay, so our D2 is in this one and D3 is 1. Okay, so finally D2 equation is what? I1 I0 bar, and D3 equation is I1 I0. Okay, and what is the operation performed? No, I1 I0 bar plus I1 I0 whole bar. Can you solve it?
Yes, sir.
So apply the De Morgan's I1 I0 bar whole bar dot I1 I0 whole bar again. So I1 bar plus I0 multiply with I1 bar plus I0 bar. Okay. A plus B, A plus C. What is the formula? A plus B. Okay, so I1 bar plus I0 bar. That is 0 I1 bar. Now what is I1?
Why?
1. Okay. Any doubt? Yes, any doubt?
Sir, could you scroll up a little?
Mhm.
Okay, sir. Okay.
Okay. In a similar type of question, I think you have a graded assignment. So I just solve this particularly this one with some logic changes. So what should I do here is that the circuit I'm not changing. I just change the logic. Okay. When I naught and I1 both are 0, then D3 will be 1. If 0 1, D2 will be 1. If 1 0, D1 will be 1, and if 1 1, D0 will be. Now can you solve it?
Yes, so we can try.
Yeah.
Sir, answer is 1.
Answer is 1. Okay, let's check. So we know that only D note and D1 is required. Okay, so we just only consider D note, D1. Okay, and I1 and I naught. Okay, so D1 is 1. Sorry, D naught is 1 when both are 1, 1. Okay, and D1 is 1 when I naught is 0 and I1 is 1. Okay, so for this one, the table is I1, I naught. And for this one, it is I1, I naught bar. Okay, so we consider that this is a Y. So what is Y?
I1
I1, I naught dot I1, I naught bar and whole bar. And if I'm going to solve it, so it is I1, I naught bar plus I1, I naught bar, double bar. And if I break it, so it is I1 bar plus I naught bar plus I1 bar plus I naught. Okay, so we are getting a 1 in this situation. Okay, so I naught bar is 1 and 1 plus something is always 1. So Y is 1. Okay, now for the second decoder, what is the F? F is D2 plus D3 bar. Okay, so we required only D2 and D3. So D2 and D3. Okay, we are taking I1 and I naught. Okay, now here is the point. The point is that I1 is 1. Okay, I1 is 1. So I naught possibility is either 0 or 1. Okay, so if I1 is 1 and I naught is 0, D2 is 0. Okay, because I1 is 1 and I naught is 0. D1 is 1 except all are 0. Okay, so D2, D3 both are 0 here. And similarly, when both are 1, so D0 is 1, but D2 and D3 is 0. So that means we are getting a 0 here and we are getting a 0 here. Okay, if both are 0, apply on the NOR gate. So we are getting output is 1. Clear? So the output is 1. Now can you try this graded assignment question? I think you will get the better correct answer. Question number 5. So first of all, I just say that this is the F1. What is the F1? Equation of F1 is what? I naught S bar plus I1 S. This is the equation for 2 cross 1 marks. Okay, so we write the equation. Now we put the value of I naught and S. So I1 is 0, S is C, plus I naught is B bar and S is C, so C bar. So this is 0. So F1 we are getting as a B bar, C bar. Okay, now this F1 will be applied at a S for second mass. Again, we write the equation. F is I naught S bar plus I1S. Okay, so I naught is 0. So I think we multiply with 0, always 0. So this term is always 0. I1. I1 is A bar. Okay, and S is B bar. B bar. So finally F is A bar, B bar, C bar. Clear? Any doubt?
No, sir.
Okay, now which is required? That is equal to A plus B plus C whole bar. So 3 input NOR gate. Question 6. Okay, parity encoder. So we will solve after the complete the parity encoder. Question number 7. Okay. So basically, if you see this particularly, okay, this bubbles. So this is called the active low device. What is the meaning of active low devices? Normally, the enable is what? When according to the A and B, or basically I1 and I0, we see that D0 is either 0, 1, only 1. Okay, if we apply the 0, 0. Okay, if we apply the 0, 0, so we know that D0 is 1. Okay, but because of this one bubble, D0 is 0. Because of this bubble, D0 is 0. So that's why this particular device is called the active low device. Why? Because according to the input conditions, our output should be high in the decoder. But because of this bubble, or basically because of this inverter, the output is low. So that's why it is called the active low. Clear? Now,
Sir.
the input is enable I1 and I0. And output is D3, D2, D1 and D0. So when enable is 0, okay, anything we apply on that one, we are getting a all are 0. Okay, now because of this enable is 0, this bubble we are applying 1 here. Okay, 1 will be inverted by this bubble, so we are getting enable is 0. Okay, and if 1 is C bar is 1, so that means C is 0. Okay, so when C is 0, we apply any of the input, output is always 0. When C is 1, that means C bar is 0. 0 if apply, so because of this bubble, enable is 1. Okay, now if both are 0, we are getting a D0 as a 0 and all are 1. Okay, general scenario is what? When both are 0, D0 is 1 and all are 0. But because of this active low, every output is complement. Okay, C is 1, 0, 1. D1 is 0 and all are 1. C is 1, 1, 0. D2 is 0 and all are 1. Okay. And C is 1, 1, 1. This one is 0 and all are. Okay. So can we write the equation for the D note? So that is, in the I note we connect a B, in the I1 I connect a and C is 1. Okay, so we can say write then A bar, B bar, C. D1 is not connected, so we are not write the equation for D1. D2 is A is 1, so A, B is 0, B bar and C. And for D3, A is 1, B is 1 and C is also 1. Okay, and all three are connected with the in the main pin. So can you write the equation? Now what is the asking in the question? They are asking the equation. Okay, so from these two equations, I just take a C as a common. So it is AC as a common. AC. So remaining is B bar plus B plus A bar, B bar, C. Okay, this is 1. So remaining is AC plus A bar, B bar, C. Now from these two, I am taking C as a common. So it is A plus A bar, B bar. A plus BC formula. So C, apply the distribution law. So A plus A bar and A plus B bar. So this is 1. So C, A plus B bar. Okay. Okay. Now a multiplexer, 8th question, select the correct option. A multiplexer cannot be used as an encoder. So we already know that a multiplexer and decoder both are almost similar. If we connect a basically OR gate in the decoder, that will be similar to the multiplexers. Okay, so multiplexer and decoder, we can say that both are similar. Decoder with the OR gate we use as a multiplexers. So it says the multiplexer cannot be used as an encoder. So that is correct, because multiplexer can be used as a decoder. Okay, no, not a multiplexer. Decoder can be used as a multiplexers. Decoder with OR gate will be used as a multiplexer. Okay, and second, a multiplexer select one of many inputs, whereas the encoder convert the valid input to the binary code. That is also correct. So statement 1 and 2 both are correct. If 2 raised to power n is the number of output lines in the available decoder and 2 raised to power capital N is the number of output line in the desired decoder, then the number of available decoder required to construct the output stage. 2 raised to power capital N minus small n. Like for example, we have to design a 6 cross 64 and we have a 2 cross 4. Okay, so according to this one, so output line is 4, 2 raised to power 2, and the required output line is 2 raised to power 6. Okay, so it says that the required is 2 raised to power 6 minus 2. So 2 raised to power 4, 16. Okay, so we required a 16 decoder in the last output stage, last level. So that is correct, because you already see we design a particularly, yeah, we design a this one. Okay, so if we have a 32 lines and we have a 2 cross 4, so how many we required? 2 raised to power 5 minus 2. 2 raised to power 3, that is 8. So we required a 8 decoder in the output stage for the last level. Okay, the last question is, so it says that the time delay for mux is 6 nanosecond. Time delay of OR is 4 nanosecond. Time delay of NOT is 2 nanosecond. Time delay of NAND is 3 nanosecond. Okay. So what is the OR is 4, NOT is 2, and 3. What is the worst case delay at the node F? Okay. So like for example, we apply A at a G nanosecond. Okay. So we are getting the output here as 2 nanosecond. Okay. Similarly, if we apply the B and C at a 0 and 0 nanosecond, so we are getting a 4 nanosecond. Okay. So which one is the worst? 4 nanosecond. Okay. Like for example, you two persons are going to leave for a one station to another station. Okay, this is the station 1, this is the station 2. Two persons are leaving at the same time. So if it will be approaching at 10 a.m. and the second person will be approaching at 11 a.m. So which train you are basically catch from moving from one station to other station after 11 a.m. Why? Because you both will be the going together. So you have to the person who reach at 10 a.m. they will wait for a 1 hour. After 11 a.m. second person will be coming. After that they are going to catch a train and move to the second station. So similarly scenario is here. One input is applied at 2 nanoseconds. Second input is applied at 4 nanoseconds. So the first earlier one have to wait when the second input is arrived. So that means they have this particularly will be wait for the 2 nanosecond and the input is applied to mux after a 4 nanosecond. Is it clear? Any doubt?
Clear.
Okay. Now mux will be take a 6 nanosecond. So we are getting the output here at a 10 nanosecond. Now after 10 nanosecond, one input is go to the this one. So again the NOT gate will be taking the 2 nanoseconds, so it will be approached at a 12 nanosecond. This is the NAND gate. NAND gate will be taking the 3 nanosecond. So one input is approached at 10 nanoseconds. Second input is approached at a 0 nanosecond because it is a directly. Okay, so we are saying that all the input are applied at a without any delay. So that particularly D is also applied at a 0 nanosecond, but it has to wait till the second input is arrived. So that means at this point they will be going at a 10 nanosecond. After that, NAND gate will be taken a 3 nanoseconds, so it will be reaching here after a 30 nanoseconds. Okay. Now one input is 12 nanoseconds, second is 30 nanoseconds. So it applied at a 13 nanosecond. Okay. Again, mux will be taken a 6 nanosecond. So the output will be taken as a 6 nanosecond, so it will be 19 nanoseconds. So the worst case delay is called the 19 nanoseconds.
Sir, one doubt here.
Yeah.
Sir, for the first marks,
Uh,
S S is 0, so it will select I0, right?
yeah.
So what should we consider? Should we consider?
Now, yeah, exactly the same thing I am saying. This is the normal scenario.
Okay.
Okay. Now, what is going to happen here is that select line. Okay, select line. So the thing is that if select line is 0, so basically that input is not connected to the output. So if it is approached at a 4 nanosecond, there is no use of that. Okay. So when valid input will be applied, I naught will be applied at a 2 nanosecond, so it will be directly move a when S is 0.
Okay, sir. Okay.
Okay. So no need of to wait the I1. If the select line is not mentioned, it is if it is a and B, so the worst case delay is 19 nanoseconds.
Okay, sir.
Okay. But in this case, the select line is also mentioned. So that means at we know that either the S is 0, so I naught is selected as a output. So doesn't mean what is the I1 and at what time it will be arriving. Okay. So that
Okay.
means that will be approached here after 2 nanosecond. It will be take a 6 nanosecond. So the output of the first mux will be arrive at a 8 nanosecond. Okay. So 8 nanosecond, again it will be the 10 NOT gate, so it is a 10 nanosecond. It will be NAND gate 3 nanosecond, so it is a 11 nanosecond. Now S is 1. If S is 0, so after 10 nanosecond, it will be go outside. So the worst case delay is 16 nanosecond. If S is 1, so you have to wait for this one. So it will be coming at a 11 nanosecond. 6 nanosecond taken by the mux, so it is a 17 nanosecond. Okay. And
Okay.
if it is a and B, then worst case delay is 19 nanoseconds.
So if the values of the select lines are given, then we have to select. We have to see what path has been followed and select that particular thing.
Yes, am I audible?
Yes.
Yes.
Sorry for that. Yeah. So it is clear.
Yes, sir.
Now the parity encoder. The problem with the encoder is what? Encoder is what? If you are talking about the encoder, so if we have a three input I3, I2, I1 and I0, and we have a output Y1 and Y0. So encoder, it will be convert other code into the binary code. Okay. So if I say that I3, I2, I1 and I0, so it is a 0, 0. 0, 0, 1, 0. If I1 is 1, so we are getting a 0, 1. If I2 is 1, 1, 0. And if I3 is 1, 1. Okay, this is the normal encoder. Okay, if this is okay, but the problem with this encoder, two problems are there. One is if all input are 0. If all input are 0. So for example, I am taking all are 0. Then what happens? Okay, so first problem is that if all input are 0. And second problem with this encoder is that if more than one input is 1 or high level. Okay, if more than one input is high level. Like for example, we can say that 0, 1, 0, 1. Now what is out? Okay, so if second particularly problem will be solved with the parity. Okay, and what the parity encoder do, like for example, I say that the parities of the encoders will be I0 is the highest priority. Okay, so that means priority will be start from here to here. So first, what it do, it will be check I0. If I0 is 0, okay, so that means it will be moved to the I1. Check I1 is 0 or 1. If I1 is 0, it will be moved to I2. Okay, again check I2 is 0 or 1. If I2 is 0, it will be moved I3. Again check it is 0 or it is 1. If it is 0, so we can say the invalid condition. Okay, and if it is 1, so my y1 y0 is 1 1. Okay, but if I0 is 1, it is directly put the y1 and y0 as a 0 0. Okay, why? Because I0 is a higher priority. If I0 bit is 1, so he doesn't move onto the lower priority. On the basis of higher priority, it will be set the output condition. Now if you check that if you have a 1 1 1, all are 1. Okay, if you have all are the ones, so no need of that one. Why? Because it will be check I0. If I0 is 0, then it will be check I1. If I0 is 1, no need to go further because I1 is the lower priority as compared to I0. So if I0 is 1, it will not check I1, I2, I3. According to I0 is 1, it will be set the value. But if I0 is 0, check I1 is 0, check I2. If I1 is 1, so it will be set Y1, Y0 as a 0, 1. 0, then check I2. I2 is 0, then check I3. But if I2 is 1, it will be set Y1, Y0 as 1, 0. And if I3 is 1, so it will be checked Y1. Okay?
Okay, sir.
Any doubt? So that is the meaning of parity input. Okay, suppose for example, if we have a I3 as the highest priority. So I3, I2, I1, I0, Y1, Y0. So suppose I3 is the highest priority. Sorry, 0, 0, 1, 0, 0, 1, 0, 1, 0, 0, 1, 0, and 1, 0, 0, 0, 1, 1. Okay, that is the simple encoder. F1010. Okay, now what will be happen? I3 is the highest priority. So my table should be like that. If I3 is 0, then it will be go to I2. Check I2. If I2 is 0, then it will be go to the I1. If I1 is 0, then it will be check the I1. But if I3 is 1, no need to check the I2, I1, I0. Why? Because the higher priority bit will be the 1. So that will be set the Y10 as a 1, 1. If I2, I3 is 0, then check I2. I2 is 0, then check I1. But if I2 is 1, so according to this one, it will be checked Y1, Y0 as a 1, 0. Okay. If I1 is 1, it will be checked Y1, Y0 as a 0, 1. If I0 is 0, so invalid. Why invalid? Because all input are 0. So that condition is the invalid condition. Okay. And if I0 is 1, so that means Y1, Y0 is 0, 0. Okay. So you can create a basically table. Table is that I3, I2, I1, I0, Y1 and Y0. We know with the help of 4 inputs, 16 combination is possible. 0, 0, 0, 0. That is the invalid. 0, 0, 0, 1. 0, 0, 1, 0, 0, 0, 1, 1. 0, 1, 0, 0, 0, 1, 0, 1. 0, 1, 1, 0, and 0, 1, 1, 1. 1 0 0 0 1 0 0 1 1 0 1 0. Okay, in this way we can create. Okay, now if I say that y3 is the highest priority, I3 is the highest priority. Okay, so first this one, so both are 0 0. Second, this one 0 1. Third, here two inputs are 1, so it is the highest. If it is a 0, check this one. If highest, if it is 0, check next one. If it is a 1, so again 0. Okay, this 1 0. Now again the highest priority, this one as compared to this one, so 1 0. Highest priority of this one as compared to this one, it is a 1 0. Highest priority of this one, so it is a 1 0. 1 1. Highest priority this one, so 1 1. Highest priority this one is 1 1. Okay, so for all others combination we are taking the 1 1. Now if I want to check the truth table, or basically write the equation. So there are two particular equation we can create. One is for the y naught and second is for y. I3, I2, I1, I0, I3, I2, I1, I0. Okay, now when y naught is 1, the first condition when all are 0, so it is a invalid condition. Okay, now
Sir, that invalid condition we are not going to consider for anything, right?
yeah,
Okay. Okay.
okay, any particularly output is possible here. Either it is a 1 1 or it is a 0 0, it is a 0 1 or it is a 1 0. Okay, because what is the meaning of digital? Either the output is 0 or either the output is 1. Only two possibilities is there, digital.
Yes, sir.
Okay, so but that is not a correct output. So either the output is 0 or either the output is 1 is there. So we can consider that the output is not determined. So we can say use that particularly is the as a don't care condition.
Okay, sir.
Okay, now for the 2 it is 1, for 3 it is 1, for 8 2, because after that 8 I3 is 1. Okay, if I3 is 1, so that means y1 y naught is 1 1. So 8 9 11 10 12 13 15 14. Okay, so one particularly is this one and second is this one. So the equation for y naught is I3 plus, okay, we can create a group of 4 also. 2 is this one and 2 is this one. So I2 bar by, because for the first and fourth row I2's value 0 is constant, and for the column third and fourth I1 is constant. So I2 bar I1. Okay, and for y1 this is don't care condition. 4 is 1, 5 is 1, 7 is 1, 6 is 1. Then similar 8 9 10 11. So everyone is 1. Okay, so one group we create this one group we create this one. Okay, so y1 is what? If I am talking about this group, so I2 is constant, the value is 1, plus for this group I3 is constant and the value is 1. Okay, so this is the value of y0 and y1. So that is basically the parity encoder.
Okay, sir. Sir, so here I0 is of no consequence in the if we go by the equations.
Yeah, if we go by the equations, you can see that the no one in y0 and y1 both is independent of I0.
Okay.
But we have to check Like for example, if we take the this priority, like I am taking the I note is the highest priority, then equation should be different.
Right. Right.
Okay. So it is mentioned in the question that MSB is the highest priority or the LSB is the highest priority.
Okay, sir.
Okay. If any doubt, you can ask. Now in the next class, we basically discuss, just wait a minute. Okay. So till now we discussed that how we design a 3x8, sorry, lower order use lower order mux to implement a higher order mux. Similarly for the demux. Okay. Similarly for encoder and decoder also. Now in the next class we basically discuss if any Boolean expression is given. How we implement that Boolean expression using mux, demux or decoder. Okay, first thing we cover this one. Second, if implement higher order Boolean expression using lower order. Mux, demux, encoder, decoder. Then how we can implement. Okay, so in the next class we will discuss. Along with that, we will solve some gate questions, gate previous year's question.
Sir, in the questions, can you include some active low kind of questions?
Yeah, exactly.
Okay.
Okay, we will also solve the active low questions. Just basically at that time, Friday, you can recall me that one. So we will include that question also.
Okay, sir.
Okay. Any doubt you can ask. So if no doubt, we can stop here.
Yes, sir.
So thank you all.
Thank you, sir.
Thank you, sir.